Upload your doubts on the app to get video solutions.
Two bodies A and B of mass 5 kg and 10 kg are in contact with each other, rest on a table against a rigid wall. See the figure. The coefficient of friction between the bodies and the table is 0.15. A force of 200 Newton is applied horizontally to A. What are the reaction of the vertical wall and the action reaction force between A and B? What happens when the wall is removed? Okay, so these are very simple and common questions. So here we have two walls, okay, like this, and there are two masses over here, A and B, right? So first of all, this is 5 kg, so I am just writing here 5 and this is our 10 kg mass, right? So mass of A is 5 kg and mass of B is 10 kg. And what is the force applied here? 200 Newton as per the question. Okay, and okay, let's write here the information so that we can use them. So mass of A is 5 kg as per the question. Mass of B is 10 kg as per the question, right? And what is our force? Applied force is how much? 200 newtons, right? Applied force is 200 Newton. Okay, and what is the coefficient of static friction? Coefficient of static friction, because they are in rest. Okay, so static friction is how much? 0.15. I hope this is clear. Okay, so let's see now. Okay, what will be the frictional force? Okay, so force of friction will be equals to mu times MA plus MB, both the masses, into G, right? What is MA plus MB into G? That's the normal reaction, right, of both the masses. So we are just assuming it as a collectively one object with the mass 10 plus 5, 15 kg, right? So let's substitute the value of mu here. So on substituting the value of mu, how much is the mu? 0.15. What is the mass of the first one? 5 plus 10 into G. Let's assume G as 10, right? And 10 into 0.15, that will be 1.5 into 10 plus 5, 15, correct? So 15 are 225. So that will be, let's write here, which is equals to 22.5. Okay, that's the Newton. Okay. Now if the force is applied on the right hand side, where will be the frictional force? So frictional force will be in the opposite direction, right? There will be frictional force here. Let's write here as frictional force as small f. Okay. So this is our frictional force on the left hand side acting here. So what is the net force acting on the system? So let's go on the left hand side and write here. What is the net force? Net force acting on the system will be, see, 200 is applied on the right hand side and frictional force is applied on the left hand side, minus 22.5, right? So the net force acting on the system will be 177.5. And this will be right side or left side? It will be right side, right? So this is the resultant force which is trying to apply the force, okay, which is trying to push these two objects on the right hand side. We have two blocks here. One here 5 kg, another one here as 10 kg. And we are applying a force of 200 Newton over here. The resultant force experienced by both the blocks is 177.5. So if the action is on the right hand side, reaction will be on the left hand side, correct? So reaction experienced by the whole system will be on the left hand side. So let me write here, the reaction force, will be 177.5 Newton, okay, leftward. Okay, right side is what? Right side is the net force experienced by them. And how much they are experiencing this force? 177.5. Okay. Next part. Next is force of friction on mass A. So force of friction on mass A. How much it will be? Fa, that will be equals to mu mass of A into G, correct? Mu is how much? 0.15. Mass of the first block is 5 and acceleration due to gravity is 10. So when you multiply 15 5 is 75 and 75 into 10, that will be how much? That will be 7.5 Newton, correct? And that is the frictional force on the left hand side. Okay, so let's redraw this diagram over here. This is first block, this is second block, and this is the wall over here, and over here this is the wall vertically over here, correct? So the friction experienced by the first block will be on the left hand side. Clear? Okay, so this is the force of friction experienced by the block A. Clear? This is block B. Let's move ahead. Let's see what is the net force, okay, experienced by block A. How much it will be? It will be 200 minus the friction experienced by block A, okay, 7.5, and that is how much? 192.5 Newton, okay, that is the force experienced by block A, okay. Now, let's move to the second part, okay. So, when the wall is removed, okay, there is a second part which is saying, okay, what happens when the wall is removed, right? The question says, last part, what happens when the wall is removed from this whole system? So, if the wall is removed, right, then what will happen? Both the blocks will move right inside. So, what is the net force experienced by both of them? Net force experienced by both of them will be, 177.5 Newton, okay, if wall is removed. And in that case, they will experience some acceleration. Yes, okay. How much acceleration? So, force is equals to mass times acceleration. We know this from Newton's second law. And what is the force? Net force is 177.5 Newtons, and mass, total mass of both the system, 5 plus 10 into acceleration. So, this gives us acceleration A is equals to 177.5 whole divided by 15. And if you divide both of them, you get an acceleration of 11.83 meter per second square. This is the acceleration with which they will go on the right hand side. Done. This is the net force. Acceleration.
Watch the complete playlist on the app Pions. Download the app now.